Now, very sadly for us, matrix multiplication is not the same as addition and subtraction. It's not a matter of just multiplying corresponding entries. Instead, it is a much more complicated process involving multiplying rows by columns and adding the results of the individual multiplications of those entries. There's a lot here. So first of all, we have to determine whether a couple of matrices can be multiplied at all. And so for that, we have to look at their dimensions. And so if we take a look at the two matrices that are described here, matrix A and matrix B, if we are going to be able to multiply those matrices, the number of columns, meaning the second dimension of matrix A, has to match up with the number of rows, the first dimension of matrix B. If those two are not the same, so if there's not two columns in matrix A and two rows in matrix B, then that multiplication will not be possible. So that number has to be a match. So the dimensions on matrix A, the number of columns, number of rows of matrix B has to be the same. And then the resulting matrix, if you are able to multiply those matrices together, are the other dimensions of the two matrices. So the number of rows of matrix A and the number of columns of matrix B are what end up being your resulting matrix dimensions. So that's the first thing that we've got to be able to determine, is whether or not the multiplication is going to be possible at all. Then we can get into the mechanics of how we actually perform the multiplication, because again, it's not just a matter of multiplying corresponding entries like it was for addition and subtraction. So to start off with, if we take a look at this first example here, if we have two matrices, A and B, with the exact same dimensions, 2 by 3 for each one of those, are we able to multiply them? Well, if we say we have a 2 by 3 and we're multiplying another 2 by 3, our rule that those middle dimensions have to match is not satisfied. We have 3 columns in matrix A, we have 2 rows in matrix B, so we cannot multiply those two matrices. It will not work, as we'll see in the mechanics of it later. In the second example, so matrix A is a 4 by 2, matrix B is a 2 by 5. So if I write that down, I've got a 4 by 2 times a 2 by 5. This time I am going to be able to multiply those matrices because I do have a match on those inner dimensions. And so then the resulting matrix, when I perform the multiplication, will be a 4 by 5 matrix. So you can see that our resulting matrix is not the same dimensions as either of the two original matrices. And then in the last one, so we've got these two matrices, a 1 by 3 and a 3 by 1. So if I put those side by side, the 1 by 3 for A times a 3 by 1 for B, we do indeed have a match on those inner dimensions. And so then those outer dimensions are going to be the dimensions of our resulting matrix. And so in this case, we would end up with a 1 by 1 matrix. We would basically just end up with a single number as our resulting matrix for that multiplication. So once we determine that we can multiply two matrices, how is it that we do so and arrive at the final answer? So let's take a look at the example that's in front of us here. So to start off with, let's make sure, confirm that we can indeed multiply these. So here I have a 2 by 2 matrix that's multiplying a 2 by 3 matrix. So I've got a match on those inner dimensions, so that means my resulting matrix will be these outer dimensions, so I'm going to end up with a 2 by 3 matrix when I'm all said and done here. So what I'm going to do is I'm going to build kind of a giant template here for a 2 by 3 matrix. And so what I'm going to have here is I'm going to have kind of 3 blanks. So I've got 1, 2, 3 blanks in row 1. I've got 1, 2, 3 blanks in row 2. Because I'm going to be filling those blanks with the algorithm that leads me to this product. And so the way to think of the way we multiply matrices is as a row by column operation. So to start off with, I'm going to multiply row 1 times column 1. And so if we look in our matrix here, where we're going to be putting our answer, that means I'm going to be filling this space here. That's row 1, column 1 of this answer matrix. So not to clutter my diagram here, I'm going to take that away. And so what we're going to do is we're going to move across the row and down the column and multiply the entries as we go and then add those results. This is the way matrix multiplication is defined. So that means I'm going to take 6 times 8, and then I'm going to add to that, as I move across the row and down the column, the next product, 4 times -1. And so the result of that, those two multiplications, and then adding those two products together, will give me row 1, column 1 of my answer matrix. Then I'm going to do the same thing for row 1 times column 2. I'm going to perform the same series of operations. I'm going to multiply the entries as I go across the row and down the column, and since I'm multiplying row 1 times column 2, I'm going to be putting that answer right here. So as I move across, I've got 6 times -2, and then I'm going to add to that, move across the row, 4 times 0. And then I'll eventually perform those multiplications, add those results, and that'll give me the entry for that location. And then I'm going to repeat that one more time. I'm going to do row 1, but this time times column 3. So I've got row 1 times column 3. So if we do that, again, we go back to 6 times the first number in that column in the second matrix is 7. So we have 6 times 7, and then we've got to add to that 4 times 5. I move across the row and down the column. So those are going to eventually lead me to the entries in the first row of my answer matrix. And so then I need to go through and do the same thing for the bottom row, multiplying each one of the columns. So to start off with, I've got 1 times 8. So maybe I'll clean up my diagram over here a little bit. So we're going to be moving across the bottom row and then down the first column. So I'm going to be doing row 2 times column 1. So I've got 1 times 8, and I'm going to add to that -3 times -1. So I'm moving across the row of the first matrix, down the column of the second. So -3 times -1. Then we're going to take row 2 times column 2. So we got row 2 times column 2. So if we do that, we've got 1 times -2, so just taking the first number in the row times the first number in the column, and then we move across and down, and we're going to multiply -3 times 0. And then finally, we've got row 2 times column 3. So row 2 times column 3. So we've got 1 times 7 plus, moving across the row, -3 and down the column times 5. And so now I'm just going to perform this arithmetic to end up with my resulting 2 by 3 matrix. So I've got 6 times 8 is 48 plus -4, so I've got 44 as that first entry. Then I've got 6 times -2 is -12 plus 0, so I've got -12 in that second entry in that row. And then I've got 42 plus 20, so I've got 62 as the last entry in that row. Then I'm going to do the same thing for the bottom row. 8 plus 3, so I get 11. -2 plus 0 gives me -2. And then lastly, I've got 7 plus -15, so we get -8. And so this now is the matrix that we get when we multiply the two matrices that were given to us here. So let's take a look at another example. Let's first confirm that we can multiply these matrices and then determine what the dimensions of the resulting matrix will be. So this first matrix is 2 rows by 3 columns, so it's a 2 by 3. We're going to be multiplying it by 3 rows by 2 columns. So our inner dimensions do indeed match. So that means our outer dimensions will be the dimensions of the resulting matrix. So we're going to end up with a 2 by 2 matrix when we're all done with our multiplication. So I'm going to build the template like we did last time. So I'm going to make it nice and big here. And so here are my 2 entries in the first row, and here's where we'll put the 2 entries in the second row. So again, we're going to be multiplying rows by columns. So I'm going to start off with row 1 times column 1. So row 1 moving across, and then column 1 moving down. So I've got -6 times 2 plus, and then I'm moving across the row, so now I've got 2 times -4. Make sure that looks like a -4 plus, and then I'm going to multiply 1 times -1. So I've just moved across the row and down the column and multiplied each corresponding set of entries and then added them. Then I'm going to move across and do row 1 times column 2. So we'll be going down that column this time. So it's -6 times 3 plus, and then moving across the row, 2 times 0, and then one more time across the row, 1 times, moving down the column, we've got -5. So that takes care of row 1 times each of the columns. Now we're going to take row 2 times each of the columns. So I'm going to take row 2 times column 1. So row 2 times column 1, I've got 5 times 2. So I'm working down this column here, plus 3 times -4, and then lastly -2 times -1. And then one more time, we've got to multiply row 2 times column 2. So I'm going to be moving across the bottom row and then down this column here. So I've got 5 times 3 plus 3 times 0 plus -2 times -5. And so now I just have to perform this arithmetic, simplify these expressions for each entry, we'll get our result. So -12 plus -8 plus -1, if we add all those together we get -21. Over here we get -18 plus 2 times 0 is 0 plus -5. So if we add those together we get -23. In this bottom row we get 10 for the 5 times 2 plus -12. Make that look like a plus there. And then plus 2. So 10 plus -12 plus 2, we're going to get 0. And then finally for that last entry we've got 5 times 3 is 15 plus 0 plus 10, so we're going to get 25. And so here are the entries into the resulting 2 by 2 matrix.